All right, the few, the brave, the proud, you should give yourself a round of applause for making it to the last session of the last day of a fantastic conference. Awesome topics, awesome models, lots of topic models too, pun intended. And I think what I'd love to do is really just do my part to get you to the last mile, to the finish line, so to speak, in talking a little bit about how Intel sees H2O, how we see open source machine learning, and what we're doing primarily as a semiconductor company. That's how you know Intel. But you might be surprised to learn that we have also 10,000 software developers working at Intel. That's roughly 10% of the employees at Intel working on just pure software development. They're not just doing drivers, right? So they're building lots and lots of components that eventually make for some really interesting solutions out in the ecosystem. And the way we see ourselves is, in some ways, dealing with operating system issues. Because ultimately, if you look at everything that separates an application from the hardware layer, what we're talking about is as Intel being able to optimize that stack and all the components in the stack that separate an application from the hardware on which it runs. It used to be that it was really Windows, and then it was Windows and Linux. And we worked a great deal to make sure that Windows and Linux were optimized to run on Intel-based hardware. And you see now that Intel is making roughly 50% of the contributions to the Linux kernel. Now, if you imagine that as we start to work our way up the stack, that becomes hypervisors, cloud orchestration layers, virtualization, containers, data platforms, and ultimately analytics capabilities. And the approach is very similar. But ultimately, what we're seeing is that as with any new set of capabilities and workloads, we see a huge opportunity for data to transform every industry. And you've seen this before. There's tons of opportunities here. What's interesting to us as a problem statement, the reason Intel, with all of its heft and its resources, can apply to this task is that the problem statement is that we see a lot of gap between proof of concept, pilot, and production deployment of large-scale machine learning-based applications. And to us, that's the crux of being able to see this ecosystem prosper, to see industries in various domains build applications and deploy them in production. There are fundamentally three types of problems that we think that enterprises confront. First off, there's the whole issue of the security of the data. If you can't trust the data that you're ingesting, no matter how and where and what sensors it comes from, then you can't trust the analytics. You can't trust the intelligence that comes out of that data. So trust is a huge set of issues, and to us, being able to address that in terms of security, not just from an application security perspective, but the infrastructure security, data protection mechanisms, and ultimately tying them down into the silicon and having that root of trust in hardware is really important to Intel. The second part of it is really insight. It's why you're all here. It's the whole notion of being able to turn data from sort of raw material into gold. And the way you do that is by applying analytics to it, but fundamentally that's now increasingly predictive analytics, which requires machine learning, and all of that depends on being able to do this in a timely fashion, which leads us to performance. So Intel focuses on performance, and in much the same way as security, we start out looking at application performance, we see infrastructure performance bottlenecks and address those and ultimately tie them back to the silicon, because we can, in the silicon layer, accelerate a vast number of functions that eventually express themselves in the application. Now, when you put this together, what we'd like to see happen is really a proliferation of solutions. And today, what we see more often than not is that a lot of the people applying advanced analytic capabilities, inferential predictive models, and building applications with them are pioneers in their industries still. There's a lot of descriptive analysis. There's a lot of business intelligence dashboards and reports, and that's great, but not as much of the predictive applications that are in some ways automating the process of extracting insight from data and then sort of instrumenting it and then actuating on top of it. So our challenge is to start at the very top and say, let's find some use cases in every industry that become in some ways catalysts. They unlock and create a cascade or a chain reaction of deployments in that industry. So if you can find something or someone that says, I've got a really hard problem and I'm willing to invest and work with Intel in developing a solution for it, and I'm willing to share the results of that effort, that proof of concept or the pilot, and as a result of that documentation or the reference architecture, or better yet, a reference implementation, we can then replicate it, we can scale it, we can build and customize around it. That to us is a really powerful catalyst and an approach that we'd like to take. What it helps us do is identify the building blocks that that customer or client or enterprise or organization used, and identify those bottlenecks in performance or security or orchestration management that we can help address. And by the time it kind of comes out into the world, it's an open source project or an open source component that others can build upon and stitch. So as we started to do this, we actually specifically went out and looked at several industries. And you'll see some of our test cases and proof of concepts and pilots. We started out initially building a solution that would allow developers, hackers, hobbyists working with really simple gadgets based on the Intel Galileo board or the Intel Edison card to create some kind of a smart home solution, like something like your backyard sprinkler system driven by a soil moisture sensor, right? We then started to work with watch companies, and you see some of them in the news today, where we built a wearable developer platform, where this was back in 2012, 13, and 14, where we started to look for ways in which people wearing watches, and Intel eventually acquired the company Basis. You could imagine data collected from the Basis Peak Watch being used to create a number of new applications. We then started to work more interestingly with organizations that weren't just content with collecting the data, but analyzing it at scale. And I'll give you one example because it's stuck with me, and it's a very powerful example. We worked very closely with the Michael J. Fox Foundation on a project where the researchers who were funded by the Fox Foundation wanted a platform, a data analysis platform, on which they could collect data not only about the patient's genome or the patient's medical records, but also exogenous factors, things like what you could measure as their movement in the body, because ultimately the Parkinson's disease it's a neuromuscular disease, and the progression of the disease is very poorly understood, because the way it's understood today is when a patient has Parkinson's disease, they come into the doctor once every 6 months. The doctor asks them to sit down, stand up, walk 10 paces, turn around, walk 10 paces back, and sit down again, and then ask them, what does that feel like, and how does it differ from what you felt like 6 months ago? That's an extremely subjective test, and what we wanted to do is to be able to equip the researchers with something a lot more objective, measures that would allow them to look at not just an individual patient, but a whole population of patients with Parkinson's disease and draw inferences about how that disease was progressing. So the platform that we built for them, the solution that we developed, involved being able to equip every patient with Parkinson's disease with a watch that allowed us to use the accelerometer in the watch to measure the change in their tremors on their hand. Use a smartphone and an app on the smartphone and the accelerometer to look at the change in their gait as they walked and their walking pattern changed. Use basic metrics on the phone and the watch to look for changes in their sleep cycles and their patterns of behavior. And all of this led us to an inescapable fact. It's the notion that when you put all this together, when you take the sensor data, you start to apply the analytics, we see a huge amount of friction that impedes the development of a production scale application. The friction lies in the fact that there are data scientists and there are application developers, and they're different. Data scientists have their tools, their processes and their methodologies, and the application developers who typically build large-scale enterprise applications today on cloud-scale infrastructure are using a different set of tools, a different set of languages, and in many ways, different set of processes. And there's a wall that separates the two, and typically when you see the data scientist work as building the model, it's almost as if there's an inevitable stage in every development that we've seen where the model gets thrown over the wall to an application developer. And in some cases, for example, with H2O, it's extremely powerful to take the POJO and be able to wrap it inside an application, but somebody else is that application developer who's doing the wrapping. And what we see is a particular opportunity or a way for us to address the problem is to create a shared infrastructure, one place where both the data scientist and the application developer are working together, and they're using similar set of tools, and they have a huge amount of flexibility in being able to use the components and the services that they need, depending on the context. And that, to us, was the vision that led us to think in terms of a stack. And this is sort of a completely open source, 100% open source from top to bottom, stack that we were able to put together and reuse over and over again as we started to look for these solutions and deploy them. So what you're seeing fundamentally are three conceptual layers. There's a data layer, and certainly in the data layer, you'd imagine Hadoop and Spark, but fundamentally what we're looking at is a file system, distributed file system being HDFS, a variety of different data stores, because we fundamentally believe that there isn't one perfect data store. There's lots of applications that depend on MySQL, some that depend on MongoDB, a lot that depend on HBase, and so what we're seeing is the need for a variety of data stores depending on the nature of the application. What we're also seeing is a similar multiplicity in the number of analytic components. So whether it's a single data science development kit that could include a variety of models, or a variety of algorithms, or a variety of tools for data preparation through data analysis, what we're expecting to see is that they all fundamentally depend on some core common set of algorithms. And today, the implementation of those algorithms tends to be proprietary, tends to be done within an organization in a very closed fashion. But one of the benefits of something like H2O, and we were really supportive of H2O, is because it creates an open source shared library with highly optimized algorithms that can run well at scale, and it obviates the need for every organization to re-implement its own, to reinvent the wheel, fundamentally. The third part, and this is why it's somewhat unique from all the other big data analytics platforms you'd see out there, is our mashup of the core big data analytics platform with an application development and deployment platform based on cloud-native concepts. And to us, that's fundamentally a platform as a service. It's things like OpenShift or Cloud Foundry, and we based our project on Cloud Foundry. So you should kind of imagine this as a mashup of Hadoop and Spark with a set of analytic capabilities on top, all of which are open source, alongside Cloud Foundry, an open source platform as a service that allows for applications to be developed, deployed very quickly. What we've created is the bridging framework, the infrastructure, the supporting componentry that allows you to use this together in one shared infrastructure on a public cloud or a private cloud or a combination of both. Right? So you could run this on AWS, you could run this on Rackspace, on OVH.com, or on premises. And what we're now in the process of doing is really validating this with a number of different use cases. And to us, those use cases all seem to follow this just basic pattern. It's the idea that pretty much everything starts on the left-hand side with connectors of various kinds, processors of various kinds, data stores, models, and runtimes. And the one thing that you'll see consistent across the whole framework from left to right is our insistence on polyglot. It's this notion that you speak more than one language, and you should be able to, as an application developer or as a data scientist, work with both R and with Python. If you have a particular interface that you like working with, then you should be supported on that infrastructure because there's many of you and you're not the same. And so we don't expect a homogeneous group of data scientists. We see a multiplicity of data scientists speaking different languages. Likewise, we expect to see a number of different application developers working with different languages, and so each needs a different runtime, and we expect to be able to support all of them. And what you're seeing here is a framework that allows that flexibility. It gives an application developer the set of data stores that they'd like to see, provisioned somewhat elastically on a private cloud as well as on a public cloud, so it's very orchestrated. But at the same time, it's designed and targeted towards big data applications. When you dive into the analytics itself, one of the things that what we're looking to do is Intel's developed a fair bit of analytics tooling within our own organization for our own purposes. And we sort of see this as a set of capabilities or services. And today, what you're seeing in a lot of analytics toolkits out in the market are applications that create a monolithic stack around these core capabilities. What we would like to see instead is the proliferation of open source tools that can be deployed independently as services. And if you kind of see this as this microservices architectural style, it's not that far off from it, but applied specifically to machine learning and to model development. These are all stages, and if you imagine that, one way I could have put this together is in a single line that starts with data preparation and ends with application integration. In reality, it never functions as a straight line. You go from data preparation to model training, and you decide during model training that you messed up on the data preparation, you go back, and so there's a whole core diagram between all of these stages, and we think that applications that depend on machine learning should have the ability to use a variety of these services and compose them and orchestrate them together. So when you actually deploy it, Trusted Analytics Platform, or TAP as we now call it, what you end up doing is creating these choices. You could deploy it with a pre-existing Hadoop cluster, or TAP can provision the Hadoop cluster for you. And because we're Intel, we have a very strong relationship with Cloudera and a strong partnership that lets us work closely with them. We've partnered to develop and test and validate this entire architecture with CDH. So you'll see us kind of using that as a default, but it's an entirely open source project, so it's certainly available for customization. And speaking of customization, the way you would see this is that fundamentally what we've got is the core TAP project as having this foundational set of capabilities. But when it's deployed on a particular infrastructure as a service, and whoever's deploying it or operating it can highly customize every component in that stack. And then when you ultimately see this in production, what we're expecting to see and what we're working with are a number of customers who are creating applications purpose-built for that stack. And this is what that community looks like, of people who are working with us to develop applications, deploy them, and customize the platform. And we're really proud to have, as part of this community, as a growing community, partners who are certified to run TAP, this platform as a service designed for analytics, on their cloud service infrastructure, partners who bring capabilities into the platform that's tightly integrated, and H2 is certainly a large part of that, specifically for the analytics and model building capabilities, and partners who take it to market. So these are system integrators and solution providers who provide support and services for all of the components. So when you deploy it in production, and the enterprise wants support and services, they can turn to Accenture or Infosys or the Silicon Valley Data Science Organization for that kind of support and services. And the project itself is 100% open source. It's on GitHub. You'll see it at trustedanalytics.org. We like to call it TAP, and one of the things that we'd love to see is obviously the combination of H2O and TAP be seen as tap water and be as ubiquitous as that. And so with that, I want to thank you for your time and attention. I know it's been a long few days, but really appreciate your time. Thank you.
Thank you, Vin.